Up to this point in time, we've talked an awful lot about people, and people are important. That's where it all starts, with our people, our most valuable asset. We've talked about management, we've talked about teams, and we've talked about individuals. Now we're going to go into the next step. If you think about quality, quality is doing things right every time. But we really want to go beyond quality. We want to go to perfection, and perfection is doing the right thing right every time. And that means we're going to go into our processes. What we have to do to have error-free performance is to change the processes that we're working with, to get them so they will allow the employee to do error-free work. And we're going to look at that now, and we're going to talk about process qualification, how you can ensure that the processes we're using are going to allow the employee to work and do his work right. Why is process qualification important? Well, it reduces the development cycle because we really can work together and collapse that. And getting a product out to our customer fast gives us a marketing advantage, a very important part. Secondly, it reduces the amount of engineering changes. And if you look at one of the measurements of the excellence of our engineering design, it's the number of times we have to go in and modify it. And so what we want to do is to reduce that down to the point that when we release the product and start shipping to our customer, we never have to go back and make a change because it gets very, very expensive to make changes at that point. And third, process qualification provides better products because instead of going through that old bathtub curve that we've all seen where you start off that new model of car with all of its problems and eventually 3 years later it levels out and it's a pretty good car. We want to have that first car that runs off that new production line come out and be high quality, as good as the car that's going to be manufactured 5 years later. So that's what process qualification is all about, getting our processes evaluated and stabilized so that they're under control when we start with them rather than wait until after we've been producing them. So what it is, it's truly a preventive activity. We talk about prevention. Here is one that is just purely prevention. It's how you go about ensuring that you have a good design and ensuring you have a good process. Now, when you start thinking about product and processes, today it's very hard to separate product from the process. You know, the engineering design and the process that's used to make that product are almost integral. They mesh together like gears. They're not an independent thing. And so what we did in the past, we have continuously said we were going to do a design and get a design complete, and then we're going to go back and we're going to see how we can manufacture that design. And we can't afford to do that anymore. And what we're doing at the present time is a thing called quality function deployment. And here what we do is we go out to our customer and ask the customer, what do you really want in a design? So it starts from what we call the voice of the customer. And that voice of the customer comes back through a matrix of decisions where we reflect that voice of the customer back into the engineering design. And once we have the design, we use the same technique called quality function deployment, where we apply the design and that voice of the customer back down into the process. So those two things come together, and so that we have a process and an engineering design that truly meet the customer expectations. And that's called simultaneous engineering or concurrent engineering. We no longer can do things in a row, in serially. We got to do them in parallel. We've got to bring up our manufacturing process at the same time our engineering process. And we used to be like this. And you see what happens when you're doing something like this? You've got a long delay. But if we can move this back in here and start doing our engineering and our manufacturing process design at the same time, we can get out to the customer much faster, meet our end objective. And that's what we're really trying to do. And that's the reason that it's so important that we do early involvement of our manufacturing and quality engineering back into the development cycle. If you start to think about the development cycle, first of all, the first phase is a study phase. And here, you're trying to study the possibilities of bringing out a new product based upon customer expectations and your ability to produce something. Really, that's a commitment. Are we going to do a project or not? The next phase you go into is the design phase. And here you're trying to develop an idea. Can we produce a product? It's a commitment to production. The next phase is the development phase, where you're developing the product to the point that you can release it for manufacturing. The next phase you go into is a pre-production phase, where you're proving out your manufacturing process and ensure that you can manufacture something that will reach your customer. And then you go into the last phase, which is the production phase. Now, those phases take a long period of time. They're stretched out over a long period of time. And what we need to do is to work on collapsing those together. And if you think about it, there really is two separate activities. And so we really want to think about it in that way. They're separate, but they're joined. We're going to march arm in arm down the aisle, but we're going to end up at the end instead of doing it in a serial fashion.
So you're talking about really getting things happening parallel.
Yes.
In other words, collapsing these so that in many cases they're happening as part of one, and then resulting in reducing the cycle times and the costs involved in that, and also getting it right the first time.
Absolutely. And what actually occurs is you can almost treat those as separate ones as long as they're closely interwoven. And when you start talking about the design, there's a whole series of tests and evaluations that are important to ensure that that design will meet the requirements. And the manufacturing process then has the same requirements too. As you bring up the manufacturing process, you need to look at what's happening. You have a manufacturing process when it's in development. Maybe this is on a table like this, where you're building your product and it's just a laboratory model, but it is truly a manufacturing process. It may be a long manufacturing cycle, but it's a manufacturing process that we have to go through. Then you go into the pre-production phase, and that's another process where you're trying to prove out the theories of manufacturability. And the last phase is the production phase. And each of those phases need to be evaluated and compared back to what the customer input was, and is compared to the design requirements that are paralleling these. Let me give you a couple definitions so that as we discuss this, we're both coming from the same point. First of all, we're going to use a term called certification. You certify individual activities, individual operations. We'll take this operation, it may be a ball milling operation, and we'll certify that as being capable of doing its intended job. So we evaluate that as an individual activity, each activity. We'll also be using a word qualification. Now, qualification says I'm going to tie all of these jobs together, and I'm going to start with materials here, and I'm going to run them down through the process, and coming out of the process is a product that meets my customer expectation. That combining of all the processes together we'll call qualification. We'll qualify that product for shipment to our customer. And so that's what we really want to do. We want to have a qualified product to go to our customer before we ship the first one, and we want to know it's qualified. We want to have a high degree of confidence that the first product and every other product that follow will fall in the same mold, that they'll all look alike. And that's what we're going to do in qualification. Now, when we start qualifying a process, there's really three individual activities that take place. First thing that we'll do is we'll certify each and every step, saying that this step can do its intended purpose, that by itself it will do the job. That's number one. Secondly, we'll run a stress run down through here, lots of product down through here to evaluate the yields and measure the stability of this process. And thirdly, we'll bring in an outside group, an independent audit group, that will audit the process and the people that's performing the activities, the support function, to say, is this process really ready have we met all the requirements? And that's the phases that we'll go through in qualifying a manufacturing process. When you start talking about this individual operation, certifying this operation, how are you going to evaluate it? Well, first of all, you've got to do a document analysis. Is all the documents required to support this there and in usable shape? You look at the manufacturing process instructions. Are they understandable? Can the people that are using them read them? Or were they written for PhDs? So you evaluate that. You evaluate the inspection procedures. You look and see, is there training requirements called out for this operation so I can train somebody else to come here and perform this job? Or can only one special person do that job? Mm-hmm. Do we have documented training requirements? Are the software controls? Do we have prints for all of the test equipment? So in case we have to build another piece of test equipment, can we do it? Do we have workmanship standards? These are the documentation that supports this. Along with it, the planning for testing. Are we going to stress test this? How are we going to evaluate this particular activity? Do we have procedures in place to collect data so you know what's happening here? Let's say first a document analysis of that particular operation. Then you can look at the test process itself. Each piece of testing activities, and we said this was ball milling, let's move down here to the testing activities related to that. Here we have a piece of equipment that's may be good or may be bad. We don't know. We have to first do an accuracy and repeatability study to determine the accuracy of that equipment, its capability of making the measurements that you want to do. You have to determine what's going to happen to this equipment over time. How will it drift? How will the adjustments drift with time? What is the error that's involved when a new operator moves in? So you've got to evaluate operator error. And as a result of all of those statistical evaluations, what you do is establish guard bands on your specification because you never want to ship product that does not meet spec. So you establish how much, if your specification is this big, and you know you've got errors in your equipment due to operators, due to drift, due to accuracy and repeatability, you need to put a guard band in that says we're going to operate within a narrow range to say that this product is good. Remember, we want to have 100% good product. We can't take a risk in shipping something that the test equipment was wrong. So we've got to put guard bands in. We've got to determine when this equipment's going to be calibrated. Is it being calibrated frequently enough? Is it being maintained correctly? Have the people that's going to maintain this equipment been trained properly? You see, what we're really trying to do is to look at what are the things that could occur to us, what could happen to us, and then we're trying to assure that we've put something in place that's going to prevent that from ever occurring. Mm-hmm. That's the way you get to error-free. And last, certainly you want to control the software and make sure that there's control over the engineering change level of every piece of software that interfaces with that piece of test equipment. We looked at the documentation. The next thing you move on to is the operations, the manufacturing operations themselves. You know, do we have an operator certification program? When we bring an operator into this job, how do we know he's ready to perform it? Do we do an evaluation? There should be operator qualification programs for all operators. Ensure that they can do their job before they move on. You need to determine, do you have control over non-conforming materials? If we do have a problem down here, what happens to that part? Does it continue on or does it get sidetracked? When you start looking at the manufacturing operations, there's a whole bunch of special things you have to look at, like if it's a clean room, has the clean room been controlled? Is the packaging, the containers, will they truly protect the product that you have? Doing drop tests. The complete container analysis is a very important facet. You have to look at how you're even cleaning the room, because cleanliness is very important. So there's a whole myriad of things that you have to evaluate to determine that that operation in that particular condition can be certified. And certainly, one of the things when you start looking at your manufacturing process is the whole concept of just-in-time. What we've did over a period of time, we've built in just exactly what we've got laid out in here. We've had a process where we do something, we put it in stock. We have another, eventually they turn around and he grabs parts out of stock, he does something and he puts them in stock. And it goes on down. Each of these weight points is waste. And what we need to do is to eliminate all of these waste points and move these back to back so that we're really moving forward. And when you do that, you have huge savings, not only in the cycle time, but in space. And space is money. Campbell Soup estimates that their stocking area costs them 53 cents on a dollar. Now that's a lot of money, and that's a lot of waste that we see all over the world. So the whole concept of just-in-time manufacturing and getting away from all the just-in-case stock is an extremely important theory that has to be built into this qualification process. We have to design the layout within your manufacturing process so that it will accommodate this type of movement all the way down through. Very important. Now what happens when we do this, certainly a just-in-time system works on what we call a pull system. You get an order in, the order stimulates the start of a process. Not the fact that we have a schedule that says I will make 25 units per day. So we're really driven by the customer orders, a pull system rather than a push system. And that's what we're looking at in this whole qualification. So in qualifying the product, you've got to look at the product design, the process design itself.
What we're trying to do is look at our manufacturing processes, much as we look at our business processes, flowchart them, reduce redundancies, and improve the process so that we are operating our manufacturing lines at maximum efficiency. One of the key efforts here is the reduction of cycle time. We know that if we produce our products in a shorter cycle time, we not only can be more flexible, but we can be better at meeting our customer demands, and that this leads us to better quality. Better quality comes about because the product is on the line a shorter period of time, and there's less opportunity for errors and mistakes. In addition, it's less costly, because one of the things that we have learned is that the longer parts or machines or equipment stay idle on a manufacturing production line, the more costly it is. We found that almost 80% of the improvements that we could make simply come about through the elimination of waste. That is, the elimination of those things that are non-productive, such as expediting, such as parts standing idly in a queue, such as parts waiting for some engineer to come over and make a quick fix on them. In terms of space, we have been able, in several cases, to reduce our space requirements by as much as 50%, while our overall production has increased. We have cases where we have reduced our cycle time to produce a product over 90%.
Now you can start talking about the product itself. You know, before you start, do you have qualified components? Have those components been evaluated? Are they coming from suppliers that have been certified and evaluated? So you have to look at the product itself. And each of the time, at each operation, when you start looking at the data that's collected from this operation, you want to look at it and say, what's happening to it? Now, we've talked before about variability and how important variability is to us. When you think about that, everything, no matter what you are, height of people, ages, there's a variation. And you'll see a normal curve, like this curve behind you, this white curve. A normal curve develops around everything, and everything varies. No matter how minute it is, maybe you can't measure it, but it varies. And there's that normal characteristic of variation that occurs. So part of the thing, when you're evaluating your product and qualifying your processes, you've got to ensure that your processes are capable of producing product that meets the engineering specification. And you want to do that statistically. You want to do a statistical analysis of that variation.
Seems like everything that we've done up to now, Jim, has kind of led from managing people to managing statistics. And then people in their teams and individually using the statistics to reduce that variation, to improve the amount of variance that you'll allow each time they get together and look at the process.
Certainly statistics is a very important tool. It's one of the tools that people use. And it's one of the tools that we use to prove that we have a process and provided the employee with a process that they can operate in error-free. And when you do your analysis, when you're doing your certification test, you should take a large enough sample that you can make a frequency distribution that will show you what the extremes of the product is. And prove that the process, each operation is under statistical process control. That means that certainly that 99.6% of the product will fall within the engineering specification. And really, if you're looking at saying that the process is statistically under control, you're really looking at what we would call a CPK, and that is the ratio of the engineering spec to the actual distribution of the 99.6% of the product. And what you would like to see is the actual distribution be about half the size of the specification, so you've got some leeway for you to drift in. And that's what we're looking for.
Building drift, but within the specification. So your objectives are more like this, which allows
you to move. Yeah. A good CPK for process qualification, when you say the process really is qualified, is a CPK of 2. Or in other words, you should have 6 sigma limits to your process. And certainly it became very, very apparent, and the importance of that has been demonstrated by Motorola with all the publicity that they've got related to winning the National Quality Award, and their quality program is based upon the 6 sigma limit of all of their processes. And that strives for world-class quality, and that's what we're really looking for, world-class quality. And you get that by using design of experiments. If you're outside that specification, the first thing you've got to do is eliminate the unexpected variation. You've got to first bring your process into control so that it's constant. And when you look at it as being constant, then you can say, does that meet spec or not? And if it doesn't meet spec, then we have to work through design of control, design of experiments, to evaluate what factors will collapse our variation down to an acceptable level. So the whole theory of design of experiments is very, very important in the early engineering phases before you qualify your process, because it's what allows you to qualify your processes.
Well, Jim, that brings us to the exercise. I think you're going to have fun with this one. It's called a negative evaluation. And what we want you to do as a team is to look at all the ways in which you can literally cause the company to fail. In other words, drive customers away. That's right, drive them away. What can you do that would be so bad that if it continued over a period of time, it could literally cause the company to fail? Well, have fun with that one. Well, you probably had a lot of fun with that, and you found out there's an awful lot of ways in which we can keep customers away. What we need to do now is look at ways in which we can neutralize all of those threats and literally prevent those conditions from occurring. Well, Jim, that was a valuable process.
That's the benefit of negative analysis. Look at what problems you could have and go in and correct them. And that's really what we're doing with process qualification. We're preventing any negative situation from ever coming up. And so you first start by evaluating each operation. And we just completed that. We've looked at that operation. We thoroughly know it. We've characterized it. We understand it. And we've eliminated any possible bottleneck to the operator before we put that operator into that operating condition. Now we're ready to do the next step in process qualification, which is running our qualification lots. And what we want to do here is we've proved that this one works, and this one works. But maybe in between here is a bottleneck. In between here is something that does not connect. And so what we want to do is to take and run our process as hard as we can to be sure that we can run through this and maintain continuous flow. And this is where we'll collect statistical data about process capabilities. We'll also determine yield rates, and it will prove that what type of production quantities we can put out over a period of time. One of the big mistakes that companies make, they promise they'll deliver more than they can because they really don't understand the capabilities of the process, the totals. And that's what we do with the process qualification lot. We stress that whole process and prove that it links together in a continuous flow manufacturing operation. Important words today. Continuous flow, no stop, no bottlenecks. Continually moving product through it. And what we do, we evaluate yields, we look at the process flow, we get down at the very end, and we'll take this initial sample off and we'll evaluate it in a test laboratory under customer simulated conditions to be sure that we really meet that customer voice. Remember way back at the beginning of this session we started talking about quality function deployment that reflects the customer voice. Now we've got product that we can bring out and put in a customer simulated conditions. Frequently, those are test customers. Other times they're laboratory experiments, but we need to take that product and put it into a customer environment to prove out that the process is capable of meeting those requirements. And that's the cycle that we go through in qualifying a process. Not quite done yet. Did a lot of work, but you know, it's the old story. If you take time and do it right, you don't have to go back and do it over. And you just cannot afford to go back and do things over. We cannot afford all the recalls we have in automobiles today. We've got to do it right. And so we're going to take just a minute more, and we're going to bring in a whole group of independent people, people that haven't been working on this program, not these people that are deeply involved, that it's their program. You know, we've made them feel that it's their program. We're going to bring an outside group in, maybe somebody that's from a completely different area, to come over and do an independent audit to make sure that all of this has been done correctly. And not a long audit, something on the order of 3-4 days where they come in, they review everything that's been going on, we make presentation to them, they look at the data, and they just give an independent review and say, what problems do we see? Have you missed any? You have a tendency when you've been working on a product for a long period of time to sort of live with some of the problems. You knew it was a problem initially. A year ago you recognized it, but you've got so used to it now that it sits there beside you and you don't see it. And that independent audit is the last step because that ties it all together and say, we haven't missed anything. And when you've got that completed, when you've completed those 3 steps, probably one additional thing you need to do is do a regression analysis. You want to compare the data that you're collecting here off the final manufacturing process to the data that you collected initially when you released the engineering design to be sure that the variables data fall into the same patterns so that they are the same product, that it is based upon the design. And that's called a regression analysis. And you're done. You're ready to go into that final phase. You can start shipping to customers.
It's all that simple.
Very complex. You know, we've had a lot of fun talking about people and teams. Well, this is the technical aspect. And quality is technical as well as people-oriented. And this is a technical issue. And improving the process is a very important part of that whole technical assessment. And we have to have strong technical assessment done by strong technical people if we're going to succeed.
We use SPC on our process line. As an example, in a wave soldering process, we are contract manufacturers who build boards, build boxes, electromechanical assemblies, and the wave process, the solder paste in our SMT area. We do both variable and attribute data, SPC, and we use it throughout our line. We also use it in our materials area in terms of materials handling in our warehouse, kitting on time, the quality of the kits, the quality of our purchases, the quality of our quotes. We also look at it in the area of our customer selection in our marketing process. Quality of our customers and how we pick our customers are very important because it ripples through from the beginning. And we also do it in our finance area. So in our human resources, we monitor in our indirect areas satisfaction of our services, the timeliness of our service. We look at each one of our function as providing a service. We look at everybody as a customer and also a provider of services. So we use it throughout our company, and it's been working out very well. Measurements are very important to us. I think it's important that we all understand what the goals are, and it's up to the people that are doing the work to decide how tactically they're going to achieve those goals. But it's important to understand what the goals are, and we do it through SPC.
We make the chart for each station. There's a whole monthly report to put all the defect rate you put over here. Then the whole month we can calculate the chart up there each month, how many defects you make in this month. And we're going to what kind of defects you are making, what kind of defect you're making. Then we analyze it and cut it down and take action on it. Before, we didn't use SPC control. We don't know what the problem is. Usually they happen in the process or happen on the materials or happen by the employee himself. We didn't know. All the problems come out all mixed up together. And after we using the SPC system and we know the rejects happen and we analyze it and we know where the problem is, so we can trace back to the source to correct it. That's why we're using the SPC system helping us a lot. That's why we from 30 defects a day to 4 or 5 defects a week.
The advantages of having statistical process control and effective statistical process control implemented is many of them. One is lower defect rates, reduced cost in production, reduced number of delays in shipment due to quality problem, because the quality problems are detected and corrected early. Higher customer satisfaction because they're getting a product on time at a lower cost, at a better quality. So it was considered as an essential tool in this company in order to compete with all of our competitors here and offshore, is to successfully implement statistical process control across all divisions.
What I like most about the quality work that's going on is that it lets me know where my flow is. It lets me know if I got a problem, I can stop it right then and there. It lets me know that when I'm putting out good quality. It's that I like SPC, the work at all. I like all of them. The SPC is the best thing we could have ever got.
Everybody wants to know how well they're doing. And it's an amazing thing. Once there's a reluctance at the beginning to measure yourself as the human nature, but once you start, it's sort of fun because it's sort of like scorekeeping, especially when you start winning. And I think it's our job as our management is to provide the tools and encouragement to our people to succeed. And Winston has done a tremendous job. He's been a great teacher, and we all have jumped on the bandwagon, and we wholly endorse it as a management team. My team, the vice presidents that report to me, all of them, we're all on SPC, and it's our job, I really feel, to provide the training and the tools for our people.
What we have now
Really, we've got the process all laid out. We've got the measurements in line. We understand the process capabilities. What we can do is we have the operators now maintain statistical process control charts, and engineers don't have to run the process. Who runs the process is the operator. They can take care of it themselves because now we know the process is capable of doing the job, and we've provided them with the tools and training and time. Remember those 3 T's? Tools, training, and time? We've did that. We've got it here and we've qualified it, and now the operators will take over and they'll run that process better than engineers ever could.
Training, tools, and time. Well, Jim, when all 3 are addressed and the proper tools applied, we're 1 step closer to that total quality management target. And it's a moving target, always higher and higher and higher. But that's continuous improvement. Well, next time, Jim will show us how to focus our improvement efforts on our processes, not just manufacturing processes, but all the business processes in the company. And we're going to focus on a general tightening up on the way things get done.